So there are a number of ways of calculating the earth pressures on the retaining wall, and this is probably the simplest, presented by Rankin. And so you have the coefficient for active pressure, Ka, given by the simple formula here. Similarly, you've got Kp, which is pretty much the inverse of Ka, and where you've got the coefficient of pressure at rest, that's an even simpler formula given there. Now, for the active pressure to be mobilized, we're assuming that the wall is flexible and that the top of the wall will move. If the top of the wall doesn't move, or assuming that the wall is rigid, the pressure on the wall is governed by the earth pressure at rest coefficient. Now, there's lots of assumptions made for the Rankin earth pressure parameters. Here they are. I won't read them all out, but basically you're assuming that the wall is vertical and the ground is horizontal. At the backfill, it's also horizontal. A slightly more complicated one, because things are not always as simple as shown in the Rankin formula. We've got some earth pressure parameters provided by Coulomb. So your slope of your ground behind the wall can be represented by beta, the slope of the ground in front of the wall by beta dash. And even the wall itself can be sloped by an angle alpha. So this makes life a lot more complicated. And to get that, we use these formula here. So the active pressure coefficient, Ka, is given by this formula. And that takes into account the angle of the ground and the angle of the back of the wall. Similarly, you've got passive pressure coefficient, Kp.